Okay, so this is part 2 of today's lesson of multiplication of fractions and how it can be looked at as repeated addition to get to multiplication. So basically, the example that they show on this page here, and you guys don't have this page, so again, this would be like if I'm projecting this from Mr. Mimio up on the board. So it says 5 times 1/3 can be represented on a number line as repeated jumps of equal distances. So you see on the number line, they broke this down into thirds. So 1/3, 2/3, 3/3 is one whole. So they're saying is if I have 5 1/3, 5 times 1/3, I can do it as the number jumps on a number line. So 1, 2, 3, 4, 5. And that takes me to 5/3. And you already know from the last video that we showed, if I have 5 1/3, it can be the same thing as 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. So 1, 2, 3, 4, 5/3. Or by multiplying just the numbers, 5 times 1, because we only multiply the numerator, is 5. 3 stays the same as my denominator, so I get 5/3 that way. So you can either do the multiply, you can do it as jumps on a number line, or you can do it as repeated addition. And that's going to be important because in some work you guys are going to be doing, you're going to be doing them in all 3 ways like this. So either straight multiply, numerator times the whole number, keep the denominator the same, draw a number line, break it into the fractional parts that it asks you to, and do jumps on a number line, or do it as repeated addition of the fraction. And how many times do you add them? That's the whole number. So 5 times 1/3 is 1/3 plus 1, and we already talked about that, okay? So one of the practice problems says, show how you can represent 4 times 1/5 on a number line. Now, you're already saying, 4 times 1/5, 4 times 1 is 4, so I know the answer is going to be 4/5, okay? But I have to show my work on a number line, so I'm going to break out my number line into fifths. So there's 0, there's 1 whole, 2 wholes, and if I'm going to multiply 4/5, so I started here with 4 jumps in, because the whole number tells me number of jumps, 1, 2, 3, 4. I end up at 4/5 on my number line. And again, now I've got my visual model to show that it's 4/5. Okay, so if you're asked to do a visual model with a number line, just break out your number line, do the number of jumps, whatever the whole number is, and then you've got your answer, 4/5. All right, question 2, show how you can represent 7 times 1/8 as repeated addition. All right, so your fraction, I've got 1/8. How many times am I adding it? Well, your whole number tells you that. So there's 1, 2, 3, 4, 5, 6, 7. Let me 1, 2, 3, 4, 5, 6, 7. And if I have 7 8s that I'm adding all together, I know I get 7 8s. 1 8, 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s. So 7 8s. Or I know you could have done this. 7 times 1 is 7 over 8, because I keep my denominator, 7 8s. So jumps on a number line, repeated addition. So I hope you're finding this pretty easy, because I think it really is pretty simple. But again, you are going to have visual models that are going to support your thinking, either with jumps on a number line or on repeated addition, okay? Now, this way is a little trickier, but it's pretty cool because it shows you a visual model. So it says 3 times 3/4 can be represented as 3 groups that each have 3 1/4 fractions in it. So look at this. Here's 4, they have 1 colored in. Here's a set of 4, there's 1 colored in. Here's a set of 4, there's 1 colored in. This is 1/4, 1/4, 1/4. That's one group of 3 1/4. So that's why they say it's 3 times 1/4. Here's the same thing over here, 3 times 1/4. And here's the same thing over here, 3 times 1/4. So what they're showing you in this model is that in order to find out how many fourths there are, so here's our problem, 3 times 3/4. Well, just doing the multiplication, you guys know, 3 times 3 is 9. Denominator stays the same. I know my answer is going to be 9/4. So how do I write that as a mixed number? Well, 4/4 is 1 whole. So 4/4 and 4/4 is 8/4. So I can get 2 wholes out and I have 1/4 left over. So I know this is really going to show 2 and 1/4 all together. So the ways that they're actually having you work on this is that, well, I can take 3 times 1/4 and I know that is 3/4. 3 times 1/4 here is 3/4. And 3 times 1/4 here is 3/4. 3, 6, 9/4. So I could add them all together. So 3/4 plus 3/4 plus 3/4 equals 3/6 Or if I did this, if I took 3 times 3/4, because there's 1, 2, 3/4 here, 3/4 is 9/4. Or if I took 3 times 3 times 1/4, right? Because I have 1/4, I've got 3 1/4 in one set, and I have 3 sets of 3. So 3 times 3 is 9. 9 times 1/4 is 3/4, or I'm sorry, 9/4. Or if I look at it this way, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 1/4. So 9 times 1/4 is 9/4. And then I get my final answer of 2 1/4 that way. So this visual model of doing groups of fractions is another way that you can represent your work. It's basically the same thing that we've been doing all along. It's just another way to do it. Okay. So on this one, it says, how can you show 5 times 3/8 using equal groups of 1/8? All right. So the easy way to go, 5 times 3, because I multiply a whole number times the numerator, is 15/8, right? So I can get one group of 8/8 out of there, and that's 8. 8 to 15 is 7. So I know my answer is going to be 1 7/8 when I get it all done. What they want you to do on this one is to actually draw 5 groups. All right, so I got 1. Oh, this is going to be hard if I'm holding my camera here. All right, we're not grading the artwork, right? I'm going to draw the other one over here. All right, so in each of those groups, I'm going to have 3/8 that are in there. So 5 times 3/8 using equal groups of 1/8. All right, so now I got to split in. They make a big fraction for me to work on. So now I got to do 8s. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I got 1/8. 1/8, 1/8. Okay, so here's 3/8 in one group here. And then I'm not going to do all this because it's going to take forever to upload the video if I did all this. But here I've got one group times 3/8. This would be another group of 3/8. This would be another group of 3/8. This would be another group of 3/8. And this would be another group of 3/8. So if I had, and I wanted to do repeated addition, 3/8 plus 3/8 plus 3/8 plus 3/8 plus 3/8 is 15/8, 3, 6, 9, 12, 15. Or I could do, well, I've got one group of 3/8 and I've got 5 groups all together. So that would be 5 times 3/8, which is the 15/8. But again, if they ask you to show it using fractional groups, you look at your denominator, that tells you how many you have to do. I know I'm going to have 3 sets of fraction sticks in each group. They're going to be divided into 8s, and I'm looking at for 1/8 of each of those groups. I'm not sure if you're going to have to do this on your own, but it's just another way to show you of a visual model of how you can look at fraction sticks to help you with groups in order to come up with your fraction. Okay, so with all that done, you guys are going to be ready to tackle your homework. I emailed your parents the homework so you can have them printed off for you, or it's already attached in Google Classroom here, and you can just open it up, look at the problems on the screen, and then actually do the work. I'm going to send out an answer key to you a little bit later on, so I want you to kind of work at it. I think you'll pretty much get it from when you get started on it. Don't forget, a lot of the work that you're going to be doing is going to be word problems. So don't forget UPBs, underline, circle, write your answers in complete sentences, write your equation with a variable. All that stuff still applies. So if you're not doing that, I don't want just an answer to the equation. You need to do all the steps of your word problems, all right? So hopefully this made sense today, that fractions and multiplication can be done together through repeated addition. It can be done by drawing different groups, and it can be done by jumps on a number line. So that's pretty much the lesson for today. If you guys got questions, post them in Google Classroom. I'll upload this video now so you've got everything ready to go. And again, answer key is going to come a little later on. All right, have a good day, guys. Talk to you later.